Okay, welcome back to how to build a SaaS service on Azure. This is part 2, SaaS architectures. So let's begin at the data layer of the solution and review the various multi-tenant SaaS database tenancy patterns that are available. Okay, so the first and often the most popular is the standalone single tenant app with single tenant database. Now, essentially what this is when you provision a new tenant, each tenant is allocated their own individual database. So here on this diagram, you can see that there's tenant A, tenant B, and tenant C, and each of them have their own isolated database that can be managed independently. In addition, there is a catalog database that's a single database that's created for managing database connections across the solution. Okay, one of the most important aspects of that is the tenant ID. Okay, so as the tenant navigates throughout your software, uh, one thing that's incredibly important is to be able to identify who the user is at any particular moment in time and what tenant or tenants they have access to. So this is the standalone single tenant and single application. So in this scenario, the tenant would be provisioned their own database and their own web application. Now we look at a multi-tenant app with a database per tenant. So on the image on the left, we see that there's one application. Okay, so for all intents and purposes, let's say it's a single multi-tenant web application, okay, with a database per tenant. So in the same scenario as our previous one, each tenant is provisioned their own isolated database with a catalog that is also provisioned to manage the tenant ID and the users who have access to that tenant. Now on the right, what we see is a similar scenario. However, the difference is that we see that they are encapsulated. So where you have tenant A, tenant B, and tenant C are all individual databases, but they are isolated. And we'll discuss that a little bit further on when we discuss elastic pooling. Okay. The third option is a multi-tenant application. Again, to focus on the multi-tenant. So that's one web application where multiple tenants are going to come in and authenticate and be authorized. Okay. And then where we have sharded databases. Now with sharding, what we essentially mean is that each tenant will reside in one of many databases. Okay, so here you see, for example, below the application, you see tenants A, B, C, and D reside in one database, E, F, J, and K in another database, L and M, and so on and so forth in additional databases, N, O, P, for example. And yet again, the catalog database also exists, and that will exist across all of the different scenarios that are available. Okay. Now here, as we're focusing in on the data layer of your SaaS solution, which is one of the most critical to focus in on when you're architecting out what your SaaS solution is going to look like. What we have here is a top-down architecture. And the main thing to identify and to realize and to notice here is that the data access layer exists within containers on Azure Kubernetes Service. And the reason for that is for obvious reasons, for needing to scale on demand, scale out into multiple nodes at any given point in time. And so you may need to do that depending upon the amount of traffic and the amount of demand that a particular tenant may have, either on an ongoing basis or at a particular time of the year. Let's say, for example, during a Black Friday sale or something of that sort. Okay, so here in this architecture, what we see is the data access layer actually residing in not just Azure SQL, but within Azure Kubernetes service in containers for scalability purposes. Now, one thing that we did notice a few diagrams ago is the encapsulation that we saw, and this referred to elastic pooling. What elastic pooling is a feature that's available within Azure SQL Server, as well as other versions of Azure SQL Server, where it's a solution for managing and scaling multiple databases that have varying and unpredictable usage demands. So let's say that you went with the single tenant database and single tenant app architecture for your data layer, and you have tenants that appear to be busier than others at given points in time, and there's just inconsistency there in terms of the amount of transactions that are existing. That's where elastic pooling comes into play. So elastic pooling is a collection of databases that is allocated X number of data transaction units, also known as DTUs. So DTUs are the measurement for transaction units in Azure SQL that can be allocated to any given database. However, in an elastic pool, you're given a large number of DTUs to share across a number of databases. And essentially, the elastic pool itself is able to allocate more DTUs at any given time to the database that needs it. Okay, so you have a set price, and you're basically sharing a set number of resources at that set price for your monthly fee for the elastic pool. And so what this does is it enables SaaS developers to optimize the price performance for a group of databases, okay, both within a prescribed budget as well as delivering performance where it's needed, when it's needed, and therefore delivering performance elastically or performance elasticity for each database. So here what you'll see is on the left diagram, it's just one database that's deployed out to Azure SQL. And you'll see that the DTU utilization is recorded on the left. Okay. And you'll see that it has some various points of peak performance. And on the right side, you'll see 4 databases, okay, also all deployed out, and you'll see varying performance demands there as well. So within an elastic pool, what it does is all the databases are given those DTUs that they need when they need it. And it's really just as simple as that. Okay. So finally here, we'll be able to look at a model comparison of each of the data access layer architectures that we refer to for a SaaS solution. I won't go into each one individually, but let's take a look at some of the ones at the top. So for scalability, we'll see that a standalone app, that's the first scenario that we looked at, where you have a single tenant database and a single application. We'll see that the scalability is actually very, very high. The ability to scale is very, very high. Now, a database per tenant is even higher, okay? And then the sharded multi-tenant scalability option is unlimited, okay? The cost per tenant is quite high for when you're going with a database per tenant for obvious reasons, right? So you're provisioning a database for each tenant that comes in, and of course, each one of those databases need to be allocated DTUs, whether individually or within an elastic pool. Now, as you go into the database per tenant scenario, into the second solution using pools, you are in fact able to bring that cost down. Now, in a sharded multi-tenant scenario, that is the lowest cost because it's essentially the smallest number of databases that are going to be deployed out, if it's not just one individually. Okay. Now, for tenant isolation, for depending upon what type of SaaS service you are providing, you may need to have your tenants isolated for compliance purposes in individual databases. And that's where the standalone single tenant and single application scenario would be of best use to you. However, keeping in mind that it's more difficult to scale that, and it's also going to be of a larger cost. Okay, so those are some of the key comparisons to look at when identifying which data layer SaaS architecture is best for you. In the next section, in part 3, we'll be looking at microservice architecture for SaaS solutions.